Hello, welcome to the second part of the Learning SQL and Python video. Today we're going to learn to calculate at first the same statistics using a sort of different method, and then we're going to even more expand on that to some more complex calculations. We're going to learn how to do pivot tables as well as histograms in SQL, which is something that you probably normally use Excel for, but obviously SQL can handle a lot more data than Excel. So without further ado, this is what we're going to cover in today's lessons. That's basically showcasing my latest project that I've learned in SQL. So the first thing that we're going to do is define Q, and we're going to continue using Q throughout the video. Then we're going to get just the first 100K records. Through this, I wanted to show you that sometimes your data set is huge, and so you only want to sort of do your calculations on the first 100,000 records so that you don't kill your machine. So you can do that in this way. And then I wanted to split the data by gender. So this is essentially the same thing that we did in the last video, gender and user type. That's also a repetition of what we did in the last video, just a little bit different, and a different method rather. And then I split the data by gender and trip duration. So I wanted to find out who rode longer. Was it women that were riding bikes longer, or men? Spoiler alert, it is women. And then I wanted to get into some more complex calculations. So at this point, we get to talk about histograms and pivot tables. I essentially wanted to know for each bike, which I identified by bike ID, I wanted to get the total number of hours that a bike was used, essentially to find out bike usage. Then from there, I bucketed the usage into 1 to 10 hours, then 10 to 20 hours, and so on, these buckets of 10 hours. This will make a lot more sense once you see it. So if you completely didn't get what I just said, no worry. The next thing that we're going to learn is something that you probably use a lot in Excel, which is string manipulation. Oftentimes, your database will give you this date stamp, which includes the whole date, which is the full date, and the time just in one full string. So what in Excel you do is you split that data into, year, month, day, and time, and you split that into different columns. You can do that in SQL as well. It's really simple, as you can see. So we're going to show you how to do that. Then let's calculate the total number of hours then that each bike was used in a given month. So I essentially wanted to know what month was the most popular, and I wanted to know that by bike, so by bike ID. And then we're nearing the end. I wanted to make a pivot table. This was really hard to read. It was just a list of bikes and then, May, June, July. And so I wanted to make a pivot table where the actual row heading would include the month. And then here would be just in the vertical, and the first column would be the bike ID. That way I could see precisely each bike and how many hours it was used in a given month. So we did that, and then the fun stuff. I wanted to know at each station, I wanted to find out whether females or males were using more bikes. That way we could conclude that in certain parts of the city, either more men live or females that use bikes, obviously, that's our full population. And then I noticed that there were a lot of males. The majority of the station usage came from males. So I wanted to find out the ratio. What's the ratio between males and females using a bike at a given station? And then lastly, since I knew the station location, I also knew whether there were males or females using those bikes. I also wanted to know the age of those people. And so I included that way. If you want to know at each station, are there males or females riding, and in which age group are those people? You can get this from this last pivot table. All right, that's for the introduction. Let's get right into it and load up Jupyter Notebook. I'm actually already in here. You are going to need some of the calculations that we did last time, so I'm just continuing in the same notebook. And so let's get started with defining Q. I'm limiting the chunk size to 100,000. Not sure how big this data set is, but just to be sure. Okay, and then let's just select everything from trip data. And when you print this, only 100,000 records should show, even though we're selecting everything. And sure enough, when you scroll down, you're going to see that it's only 100,000 records. This is helpful because sometimes, as I mentioned, you have huge data sets that you're working with and you don't want to kill your machine. So using just 100,000 records is enough. So from here, let's go on to actually seeing what columns are there. There are 16 columns that we can use to manipulate the data. You can preview all the columns here with this command. And you're going to see that we have trip duration, so we can see for each bike how long was the trip, what was the start time and stop time, station ID, so this is the location of the station, we're going to use that. Then we're going to use the birth year to calculate the age. We're going to use gender, and we're going to use bike ID, which is the way we're identifying any given bike. All right, so let's get started with some of the easy calculations that we did last time, just to sort of solidify them. And let's calculate the gender split. So using resq select, can't type, gender, and count everything from trip data is our table. And let's group by gender because we're selecting gender, and then print res. Okay, so as you can see, number one, if you remember from last time, were males, two are females, a lot more males than females. All right, so now let's do the second calculation, which is, I think we wanted to split the data by gender and user type. Then let's count everything from trip data, group by, again, you've got to group by what you select here. And of course you want to make sure you print res. And here you are. You have user type. There are two user types, customers and subscribers, and the count. There are a lot more subscribers than there are customers, except for, yeah, it looks like, except for this non-defined gender here. But if you live in New York City, it's much better to be a subscriber. I'm a subscriber of City Bike, so that makes sense. Now let's move on and calculate, what did we say, trip duration. So we can also calculate trip duration using Q. We want to select bike ID. Again, we want to calculate here the total trip duration per bike. So let's sum trip duration, right? All the trip durations. And let's divide it by 3,600 because the data in the data set is actually in seconds and we want it in hours. It's just easier to read. From trip data group by, again, we got to group it by bike ID. Sorry. And let's order by 2. Okay, so what we find out is there are a number of bikes that are used for 0 hours, and then there are many bikes that are used for many hundreds of hours. So like this one, 950 hours. Okay, so from here, just one last easy calculation, which is just seeing the average trip duration by gender. So should be pretty easy. Select gender, and then average trip duration from trip data, and then obviously group by gender. And here we can see that these are males, these are females. Females on average ride longer than guys. All right, and from here we can start going into some more sophisticated analysis. So we've calculated the number of hours that each bike was used, and that was helpful. However, let's group this data into our buckets by 10 hours. So let's do that. That's fairly easy. Again, you want to select, again, bike ID, which is the first thing that you're going to see. Then you're going to want to sum trip data, right, for each bike. You're going to want to divide it by the number of seconds that are in the hour, and you're calling this hours, right? So you have bikes written by the number of hours, and because we want to create these hour buckets, that means you need to use something called round. It's going to become a lot simpler and a lot easier to see once you actually see the data. This is a trick that you use. You basically divide by 3,000, divide to get the number of hours, and then you have to divide again by the number of buckets that you want. And I want every 10 hours to be a new bucket, right? So 0 to 10, 10 to 20. And then you have to multiply it by 10. It's kind of odd, but it works every time. And then you want to call this our bucket. That works. Now that's from trip data, and then you group it by bike ID, of course, right? And if you run this, you get an error. Let's actually see what it says. No such column trip data. Yeah, I was like, trip data is a table. Here, trip duration. Okay, here. You have a bike ID. Oh, this one is easier. You have a bike ID. This bike was ridden by 12 hours. That falls into an hour bucket of 10. This bike was ridden for 23 hours. That falls into a bucket of 20 hours. Now, why did I want to get these buckets? I want to get these buckets because I actually want to create a histogram. A histogram that will show me the number of buckets and the number of bikes that are in a given bucket. So let's do that. That should work. Nope, it did not work. Let's see what error I made here. There's a syntax error nearby. Okay. Oh, Yeah, I forgot a P. Sorry about that. And so now if you see, there are hour buckets and there is a count of bikes that are in that hour bucket. That is your histogram. You can very easily plot this and see that most of the bikes were used between 0 and 100 hours. Okay, that's your first histogram. Now I promised to teach you some string manipulation, so let's get to it. What you want to do is select start time. Remember that we are splitting the date, right? And what you specifically want to get is the date, year, month, day, and time in separate columns. So to do that, you got to get start time, which is the date stamp, and the first 10 character. And we're going to call them, this is the total date. The first, which is four character for their 4 letters or 4 characters in the year and so on, month and date. You can just copy this. You need a comma here and just change the place of the characters. So the first 4 characters are a year. The 2 characters after that are a month. And then we have day, which is, I think, 9, and it's just 2 characters, right? And then the last piece is 11 character or 11th character. That's where it starts, and it's the length of it is 10, and that is the actual time. And that's from trip data is our table again. And let's just limit it to 3. I don't want the whole thing to show up. Made a mistake somewhere. I bet I'm missing a comma here. Yep. So you can see that here is the full string. We split it into date, year, month, and day, as well as time. Super useful for more data analysis. And let's actually analyze this data further on the month that the bikes were used. So we can do that by pretty much copying this. We're going to reuse that part specifically on the month. We want to select this time bike ID. I just want month, right? I just want to know the bike ID and how much was it used in a given month. And then let's just put in the total number of times that it was used in that month. So we want to sum trip duration, divide it again by 3600, and that's okay. We want to group by, again, bike ID and month. And then let's just order by total. And mistake again, huh? Let's see. This happens all the time. No such column, bike ID. It's misspelled, sorry. Bike. All right, so this is what I meant by total. You see the bike ID. This is month July. The total number of hours in that month is 0. So 0 is came first because we ordered it by a growing number, ascending number. This is kind of hard to read because you have these months that, you know, are all in different order. So it would be really nice if we had a pivot table where you essentially had a different column for each month, June, July, August, September, and then a running total maybe, but not even necessary. I just want to see by each month how much are the bikes being used. So we can do that. We can actually reuse this, at least part of this here. This all builds on itself, as you can see, so a lot of reusable parts. So what you want to do is, again, Q. At some point, we're going to use this. Select. We want to have the first column is going to be bike ID. The second column, this is the part of the months, right? So you want to sum up. You just want to sum up where, case when month is equal to 06 is where our data set starts, and total, and we don't want any other data in there. And that's going to be June. Then you can just copy this conveniently 4 times because we have 4 months, right? So it's going to be July, August, September, no comma at the end, 7, 8, 9. All right, so we've got the column headings, bike ID, and each of the months. Now we want to get that from here. Close this, and then we want to group by bike ID. And that should work. There we go. Right? So we have the bike ID, when was it used, none was not. Here you can see, you know, June, July, none, none. So let's do another pivot table just to practice it a little bit and use the actual start station name, which is the station name where the bike is picked up. And let's see whether males or females are picking up their bikes at a given station, at all the stations, in fact. So we can start, again, this. Let's select start station name. We just want a case when gender is equal to 1 is males, then 1 else 0 and as male, and then we can just copy this, in fact, and put gender 2 is female. Let's make sure that this got a comma. From trip data group by 1, just males. All right, here it is. You can see this is the start station name. This is the station name where the bike was picked up, and the males versus females. Now you're going to see that males pick up a lot more bikes than, or there are a lot more males that are using these stations than females, which was kind of curious to me. So I wanted to see what is the percentage of men at this station versus women, just a ratio of men to women. And you can actually use that. Let's copy this formula. Right. What we want is start station name again. right, as the first column. Then the percentage, which percentage is just pretty easy to calculate. It's just male over male plus female. Let's call that percentage male. We want that from, and this is the pasted part. Okay, there it is. Station name percentage male. You can see that mostly male at those stations. Here's one where females dominate. But for the wow, there's 100% males here. Interesting. What else do we want to know? Let's, for example, actually calculate not only whether there are males at a given station, but also let's try to find out what age these people are. Remember that we have the birth year in the data set, which we can calculate the age from that by subtracting that birth year from 2017, which is our data set date. Okay, so here we want, again, the station name, and then we want age. The percentage, let's get rid of that. Let's just, I'm going to actually calculate age in the buckets of 5 because I don't want the exact age. I just want the bucket of 5. So anybody between 20, 25, 25, and 30, etc. That's going to limit this a little bit. So 2017 minus birth year. Let's divide this by 5. Again, buckets of 5. This is the same trick I used earlier on creating buckets of 10. It's just I want now just 5. So I'm writing this because I think it would be fun to also know the hour that these people are picking up these bikes at. And we know that hour is start time, the 11th character to 2 characters. So we know which time they're at the station. All right, and then the last part that we want to know is whether they're females or males. And let's just order by 1, 2, and 3, the last one, gender. Let's check out what is the error. No such column, start time. I am missing a T. There's another error. No such function substring, str. Sorry for all the typos. Okay, so you can now see the station name, the age bucket. So, 30. The hour, 1, 2 in the morning, this is. And then whether they're male or female, this is just a count. Okay, and with that, I think you know plenty. That was a pretty cool analysis. I hope that was helpful. I'm hopefully going to continue on learning more SQL and posting more videos. Thanks so much.